cryptanalysis. So see, we have already seen the two terminologies. One was cryptography and another one was cryptanalysis. So cryptography, if I write, in cryptography, we are interested in creating secret messages.
Yeah.
What is cryptography? Cryptography is the science and art
Yeah.
of creating secret codes. And what is cryptanalysis? It is the science and art of breaking that code. So in the one side, we are creating secret code, the other side, we are breaking. So the science and art of breaking the code, that is the cryptanalysis. Okay. So both are needed. It is not just that we create code, secret code. We should put efforts in trying to break those codes also. Because if we are able to break those codes, then we will be able to make it more secure. So along with cryptography, cryptanalysis is equally important.
Oh, so breaking means decrypting.
Yeah, like stealing the secret message. Despite of the secret code, yeah, we are breaking the code. Yeah, we are decrypting and we are stealing the secret message. And
Oh, so like if we do that, then we will come to know the vulnerabilities in our code. Then we can improve the code.
That is right. Vulnerability crypto systems. Okay, clear?
Yes, sir.
And hence it will helps us to create better secret codes. Interdependent. Now we are discussing relationship between cryptography and cryptanalysis. So see,
Yes, sir.
cryptography, cryptanalysis, we have interdependence, then we have advancement, and then we have security assurance. In the cryptography, interdependence, like see, in cryptography, the focus is on secure communication. So, cryptography, the focus is on creating secure communication methods, and cryptanalysis is testing those methods for weakness, isn't it?
Yeah.
Now, second is advancement. The evolution of cryptographic technique often goes hand in hand with advances in cryptanalysis. So the idea is that if we found vulnerability in cryptographic methods, then automatically we will improve it.
Yeah.
It will evolve.
Yeah.
So in advancement, I will write both are interdependent. Both goes hand in hand. Okay. Why is it so? Because see, if cryptographic algorithm increases, like if it evolves, if its quality increases, then cryptanalysis will become difficult. It will also evolve.
Yeah. The more complex it is, the more complex cryptanalysis.
So see, effectiveness is a question. Like whatever cryptographic system we are developing method,
Yeah.
there is still a question mark. Is it effective? Can we guarantee security assurance? It is still a question. And cryptanalysis helps us in answering those questions, like guaranteeing security assurance, because we are testing those communication methods.
Yeah.
Cryptanalysis is a validation. Validation systems are robust against potential attacks, isn't it? So now we got an idea that see, now we are becoming so good cyber security engineers.
Yeah.
It is not just about cryptography, but cryptanalysis is also equally important.
Yeah.
We got an idea why is it. Now we will move to the next topic. If I talk about cryptanalysis attacks,
Okay.
there are 4 kinds of cryptanalysis attacks that we will discuss. We have ciphertext only. Then we have known plain text. Then we have chosen plain text. Then in the last we have, these are cryptanalysis attacks, chosen ciphertext. So let us complete it one by one. So first we will discuss ciphertext only attack. First we will discuss ciphertext only attack. See now how ciphertext only attack works. Let us look at it.
Yeah.
We have a sender and we have a receiver. Now sender can send a ciphertext and receiver can receive a ciphertext. And ciphertext, you know, it is the encrypted text.
Yeah.
Now, interestingly, attacker, let us suppose attacker has an access to this insecure channel.
Yeah.
Because we know that in symmetric key, the ciphertext it gets transferred over an insecure channel, and the keys they get transferred over
Secure.
isn't it?
Yes.
This is the ciphertext. The attacker got access to the ciphertext that is possible. Then he analyzed it, which he can do is possible. Then he was able to convert it into the plain text. This is something concerned. This is something concerned. So in ciphertext only attacker has access to only the ciphertext, and he knows the algorithm.
Okay.
He knows the encryption algorithm because that one principle we studied now, Kershkov's principle. It states that it is okay to make the algorithm public, but private key should be so strong that it should not matter.
Yeah.
So
So sender will send the ciphertext to receiver, and attacker will attacker will interrupt and take the ciphertext, analyze it, and convert it into plain text. So so basically,
now this is analysis. Yeah.
This is happening because the ciphertext is sent through insecure channel. Is it?
Yeah. Because of that, he was able to access it. Now, from this, now he has to do the reverse engineering because attacker does not have the key, and without key also we can break the code. That is difficult, but there are some techniques available, and that is those techniques we will discuss.
And so key, how do they transfer the key from sender to receiver?
Secure channel.
Secure. Oh.
Yeah, that attacker cannot access.
Sir, if you have access to secure channel, then why don't send everything through secure only? Why insecure?
Yeah, because that secure channel has some cost involved.
Costly? Oh.
It can be costly also, and bandwidth issue will be there.
Bandwidth is?
Like the channel capacity and
all. Okay.
See, the idea is that now, if we have lots of information, it is okay to use a normal channel because dedicated secure channel, lots of information, it will not be performance wise, it will not be good. So now the attacker in the ciphertext only attacker got the access to the ciphertext. Now he has three options to break the code, to analyze the ciphertext: brute force, statistical, and pattern. And all these three we will discuss now itself one by one. So first we will discuss the brute force. So what is brute force? Brute force is making a guess, like trying out all the possibilities. That is the brute force. Trying out all the possibilities. So brute force is also known as exhaustive key search method. Exhaustive key search method. Because ultimately to break the code, the attacker needs to guess the key.
Yeah.
So he will guess all the possible keys. He will guess all the possible keys. Isn't it?
Yes, sir.
And definitely, if I try all the possible keys, definitely one key should definitely hit.
Yeah. So but for that, he should know the length of the key also, right?
So the idea is that now, if we know the algorithm, since the attacker knows the algorithm, he knows the key domain. Because with the algorithm, I will get an idea that, okay, if this algorithm is used, then this will be the key domain. Key domain means the set of possible keys.
Yeah.
If we know the algorithm, we know the key domain, set of possible keys. Since the user, like attacker, knows the algorithm, he gets an idea about the key domain. Yeah. Okay, this should be the key domain. Earlier, it was very difficult. Because brute force manually search, trying it out. But with computers, it is just matter of minutes. Yeah. Computers makes the task easy because computers are very high computational machines. Computers are very high computational machines, isn't it?
Yeah.
And so interesting it is. So it is just matter of minutes. Like, let us suppose I have an encryption algorithm, and I know that it can have in total 1 million keys.
Yeah.
In less than an hour. If I have a ciphertext, I can, because that ciphertext will be in my local machine now.
Yeah.
No attempts will be there. Like no constraint will be there. I can try it out anytime, like as many time as I want. There is no restriction. And if I try it out with all the possible keys, like 1 million keys, definitely I will hit the result. I will hit the getting it.
Yeah.
It's possible. And hence, so this script analysis made us to improvise the algorithm. Need for algorithms very large
Key domain.
key domain. In a brute force attack, the attacker tries every possible key until the correct one is found. This method is exhaustive, the exhaustive key search method, and can be very time consuming,
Yeah.
especially if the key space is large. But with computers, it's so easy. Like if I made a one program, I just have to write one program. And if it is 1 billion also, let it run. I will be drinking coffee. I will be watching a movie. I will be doing my work. Let it done. And I know that it will definitely give me the answer. It will definitely break it. Because if all the possible uh, keys it is hitting, one answer is hidden in that solution space, key domain. The feasibility of a brute force attack depends on the length of the key and the computational resources available to the attacker. It is important. Like in the brute force attack, if I talk about feasibility, so this feasibility depends on two factors. One is the length of the key is also important. If length of the key increases, the iterations will increase.
Yeah.
The computational complexity will, and also computational resource. So we need powerful systems.
So like what I understand is no matter how large the key space you make, even 1 billion, the hacker will write a program and he can find it very easily. So only thing we can do is we can improve the our algorithm, so that the hacker cannot crack it and find the ciphertext in the first place.
That is right. Now we will discuss statistical, because we are discussing analysis methods. So brute force attack we discussed. Now we are discussing statistical attack. So here we are not just blindly attempting all the keys, but we are identifying some patterns of the plain text. Identify some inherent characteristics of the ciphertext and plain text. Like, isn't it?
Yeah.
One example I will give. Mostly used character in the ciphertext.
Is it E?
It can be anything. Mostly used.
Oh, like the mostly used English alphabet is E.
No, we are not concerned about that. That is
No, I will.
Yeah, that is bit ambiguous. Like whatever is given in the notes. But see, the idea is that we have access to ciphertext, and in the ciphertext, definitely it will be in a different form. It can be in a non-readable form also. Like it can be it can contain English alphabet, or it can contain some binary data, because ciphertext can be anything. But in the ciphertext also we can identify some patterns, so some patterns they might be repeating, or all that, and we can make use of that inherent characteristics of the ciphertext and plain text. And this is also right, as you are telling, that E is the most frequently used letter in the English language. And if we can get an idea that okay, E might be present or not, it might help us.
Yeah. Algorithm should hide the characteristics of language.
A statistical attack involves analyzing the ciphertext to identify patterns and frequencies.
Yeah.
That could reveal information about the plain text or the encryption key. This method leverages statistical properties of the plain text and encryption algorithm to make educated guess. In statistical attack, we make educated guess, and we analyze patterns and frequencies. So I will see answer I have written.
Which this algorithm should hide the characteristic.
Identify patterns, frequencies, and what benefit will be that we will be able to reveal information of encryption, plain text, just 1 minute. Ciphertext, plain text, and encryption, isn't it? So this was statistical attack. Now pattern attack. Third, it is also similar.
Should hide the characteristics of language means.
It means that it would be good if there is a provision of shuffling shuffling the words, the sequences.
Okay.
Encryption algorithm should not be just masking or converting, but also shuffling.
Okay.
If it could shuffle, then it would be so good because the patterns will be disturbed.
But then shuffle, if it shuffles, then
Yeah.
it is
The frequency.
if the words are shuffled, then it will lose its meaning, right?
No. So that the encryption algorithm will take care of. No?
Okay.
See, what the idea is that encryption, decryption, they work hand in hand. They are mirror of each other. So whatever encryption process I follow, decryption, the same reverse process I follow.
Okay.
If I shuffle 1 to 2, then it will be 2 to 1, like that.
Okay.
So with every encryption comes the decryption.
Okay.
Isn't it? Pattern attack. Exploit predictable patterns. The pattern attacks, what it does, it exploits the predictable pattern. If certain parts of the plain text are known or predictable, the attacker can use these patterns to help reduce the
Yeah.
recover parts.
Yeah.
So in statistical attack, we make educated guess. We identify some inherent characteristics. But in pattern attack, we exploit the predictable patterns.
Okay.
And how to get rid of it, like the way around. Cipher text should be made as random as possible, isn't it? Okay. So this was the concept. So we were discussing cryptanalysis. So do you remember what was cryptanalysis? Like what is the difference between cryptography and cryptanalysis? There is a difference between cryptography and cryptanalysis, and what is that difference?
Like cryptography deals with creating the ciphertext, and cryptanalysis is the breaking the codes.
Okay, nice. So cryptography is focused on creating secure codes or securing the message. So we focus on techniques using which we can secure the message.
Yeah.
But cryptanalysis is basically the technique to break that code. So in cryptanalysis, our focus is to break the code. Now in the cryptanalysis, we have several techniques. Like the first is the cipher only, cipher text only. This we already discussed. Cipher text only. And what is it? If you can remember what we used to do here in cipher text only. Then we have known plain text. Then we also have something known as chosen plain text. So do you remember what is cipher text only?
Yeah, like sender encrypts the plain text into ciphertext and
Chosen cipher text. Yeah, please. Please, can you repeat? Sorry for this. Can you repeat?
Sender converts the plain text into ciphertext, like encrypts it and sends it via insecure channel. And the ciphertext is somehow obtained by the attacker. He then analyzes it and converts into plain text.
Okay, that is right. Now, if we talk about analysis, what are the different ways in which the attacker can break the ciphertext? We discussed some techniques, if you remember.
Yeah.
Yeah, like what are those techniques?
Brute force.
Brute force. And what else?
Statistical attack.
Statistical attack. And one more attack was there.
Pattern attack.
Pattern. Nice. So this, so we got an idea.
Yeah.
Now we will discuss the second technique of cryptanalysis, that is the known plain text. Let us give it a try. Known plain text. Let us see what happens here in known plain text. It will take me some time, like today itself, to become familiar with this whiteboard.
Okay.
So I might be a bit slow, not much, but yeah, because I'm getting familiar with the tools. Yeah, but the good thing is that all this will get saved. Now let us look at one scenario wherein we will understand the concept of known plain text. Now the idea is that we have a sender. Sender will send the data. Then that data will be converted into ciphertext. Like we have the plain text, and that plain text will get converted into ciphertext. Now that ciphertext and how the plain text gets converted into the ciphertext using some encryption technique. So that we already aware of. So the idea is that we have a sender and we have a ciphertext. And this ciphertext will be traveling through an insecure channel. We know that ciphertext always travels through an insecure channel,
Yeah.
so that it is prone to attack by the attackers. Like attackers can easily steal that ciphertext.
Yeah.
But we are okay with that because we know that despite of stealing that ciphertext, the attacker will not be able to cause any harm because he will not be able to understand what is written in that ciphertext, and that is what advantage we will get. And that is the main idea of cryptography, like encryption and decryption.
Yeah.
But unfortunately, using some cryptanalysis techniques, the attacker may get access, like he may break that code, he may convert that ciphertext into the real text, the original plain text. It might happen, and that is what we are discussing. That is the cryptanalysis we are discussing.
Yeah.
So we have receiver. Receiver also receives the ciphertext, the same ciphertext shared by the sender. Now, this is a normal scenario wherein sender sends the data, receiver receives the data. But problem occurs when there is an attacker in between.
Yeah.
And that attacker gets access to the ciphertext and he tries to break the code. He tries to convert that ciphertext into plain text. That is where the problem starts.
Okay.
Let us suppose this is the plain text. Now we have the attacker. So this is the ciphertext and this is the attacker. What attacker will do? Whatever ciphertext is getting transmitted over the insecure channel, the attacker will get access to the ciphertext and he will try to analyze that.
Okay.
He will try to analyze. And in this known plain text, what kind of analysis he will do? That is interesting. That is what we will discuss. That is what is something special.
Because till now it looks like the same ciphertext only.
Yeah. But now during the analysis, what that person will do is he will compare, like he already has some known plain text. He already has some known plain text that he will feed into this system, into his analysis algorithm. I'm writing that. What I'm trying to write is previous pair. So this is what is something interesting.
Okay.
This actually he will be using for analysis. So I can show just one minute. Yeah, I'm becoming familiar with that too. Yes, now it's fine. Now it is fine. So this is the idea in known. So in known plain text, the idea is that we have some known text which we think that it might be the message.
Yeah.
And while breaking, because in the brute force we make all the possible guess.
Yeah.
So the idea is that in order to decrypt, we need the key, because we are discussing private key cryptography. In private key cryptography, only when we have the key, then only we will be able to decrypt. In private key cryptography, the algorithm is already known. The encryption, decryption algorithm, we already know that, okay, this system is using this algorithm, but key we don't know. And that is the magic. Now in the brute force, what we do, we try to guess all the possible key. We try to guess all the possible key, and definitely any one key will match.
Yeah.
But in statistical attack or in pattern attack, we try to make some educated guess.
Yeah.
Wherein number of attempts we are reducing, because we know something about the patterns of the key, like we can make some educated guess. And in known plain text, we already know that this might be the information.
Yeah, like how? From where are you guessing that?
Yeah. Based on the historic data.
Historic, like
the
company previously what it sent plain text according to that.
According to that. Yeah, we will
but they won't send it again, right? Once used, they won't use it again plain text. Why would they use?
No, like see, the same they might not send, but see, the plain text which we are talking, that plain text can contain lots of data.
Yeah.
It is not that it will just contain one word. It can contain paragraphs of data also. Some sensitive information it may contain, the plain text. Yeah. This plain text may be a username, password also. Now, see, some of the data we know that it is already in public domain, like the email ID. If I want, I can very easily get to know your email ID. Now, if in the sent a text, I know that email ID and password is available. How I will know that? I will tell you. Let us suppose you try to log in into any system. When you log in, you will authenticate. In order to authenticate, what you will give your email ID and password. So whatever ciphertext we will be having, that will be having your username and password only, na?
Yeah.
Those data packets. Now, attacker, if he is able to steal that packets,
Yeah.
he knows that okay, this packet definitely contains user authentication detail.
Yeah.
And user authentication detail has to be like username and password, like email ID and password. And
Yeah.
this attacker is also able to know, like from IP address and some jugaad, some technique, he able to know that okay, this email ID belongs to this person because that is the person who tried to authenticate. And very easily from the public domain, he can get access the email ID of that person.
Okay.
So 50% of the information is already revealed.
Yeah.
Like he already knows the 50% of the plain text.
Yeah.
Now when he will be breaking the code, like
Yeah.
identifying the guessing the key, his work will be very easy because he knows the algorithm also. He knows the encryption decryption algorithm. Using the same algorithm, the 50% information he will encrypt.
Okay.
Because of which that the search domain, the solution domain in which our key might be present, the key which we are looking, it is present. That will be 50%.
Okay.
That will become 50%. So our efforts will reduce. And this is the known plain text attack.
Okay.
So this is one scenario. Another scenario is this. I will write it. So here what happens is that plain text, ciphertext like pair have been collected earlier. Now the question is that you might ask that how we will be able to get into like the plain text ciphertext. So it's very easy. See, if I know the encryption algorithm, then whatever plain text I will pass, I will get the ciphertext, isn't it? If I know the encryption algorithm,
Yeah.
whatever plain text I will pass corresponding to that ciphertext I will get.
Yeah.
So I can make a dictionary of that. I can make a dictionary that okay, if this is the plain text, this will be the ciphertext. Okay, if this is the plain text, this will be the ciphertext.
Okay.
Now, what I can do if I know the ciphertext,
Yeah.
because here attacker knows the ciphertext, he can make use of that dictionary to do the reverse mapping.
Okay.
Because see, the idea is that we are maintaining a dictionary.
Okay.
We are trying to make a dictionary, which is basically a mapping of plain text with the ciphertext. So this is the plain text. Like here we will have lots and lots of plain text, and corresponding to that plain text, ciphertext we will have. We can get it very easily because if I know the encryption decryption algorithm, if I know that okay, it is the encryption algorithm, I will just pass the plain text in that encryption algorithm, and I will get the ciphertext, and I will register that entry. Now, whatever ciphertext I am getting, using that, if it is an exact match, then it's a bingo.
Yeah.
But if it is 50% match also, or like the ciphertext which we got and the ciphertext which we have in the dictionary, if it matches 60% also, for example, then also we can make an educated guess about the plain text.
Yeah.
Like we can guess that okay, this plain text might contain these many characters.
Yeah.
I hope this is clear.
Yeah, clear.
So this is also a very interesting technique.
Yes.
And this non-plain text, it is also a bit rare. Like it is a good technique, but yeah, like it has its own complexity and it is rarely used. Yeah, but we can have it like when we are doing the cryptanalysis, we can use this technique also. Like we saw that now if we are doing the cryptanalysis, we can go for the brute force. That will definitely give us the solution because we are searching the entire domain. Then statistical patterns, statistical like frequency count and all we can make use of to make a guess, educated guess. Patterns we can make use of to make an educated guess, and this known plain text also we can make use of it because it can help us in identifying the plain text. Now we will discuss the next topic. Just a minute. I will select this and I can shift it to somewhere else. So this is what is very interesting thing about this whiteboard. Whatever topic we discussed, we will just slide it away so that we can refer it later.
Yeah.
Now we made a space for the new topic. Okay. So now we will discuss the next topic, chosen plain text. Chosen plain text. See, one of the main technique, or one of the main objective of cryptanalysis is to identify the key. It is
Yeah.
not just it is not just decrypting a particular message, but we are more interested in identifying the key. And it is so interesting that the key is same, meaning to say that I have a sender, I have a receiver. The sender makes use of a key, a private key, to encrypt the data, to encrypt the information. No, whatever information he will be sharing via that channel, he will be using the same key to encrypt the data. And if I can identify that key, if I can get that key, then the attacker, he can easily decode, decrypt all the data which is being transmitted over the insecure channel. So the main objective of the cryptanalysis, the prime objective of the cryptanalysis is to identify the keys.
Yeah.
In order to do that, what the attacker will do, like I am discussing very interesting technique with you, like this we can do if we have access to the computer or the system of the sender. Let us suppose we have a sender and we want to we want to check the private key used by the sender. Now, what I will do as an attacker, I will create one pair of known text and the cipher text. And because algorithm I know in private key cryptography, encryption decryption algorithm I know that okay, this system is using this algorithm. So what I will do as an attacker using the same algorithm, I will take one known plain text and I will create a cipher text.
Yeah.
Okay. Now what I will do, I will go to that system of the sender. There what I will do, I will send that plain text. I will send that plain text, and the system, it will make use of its own private key, because that private key I don't know, and that is hidden somewhere in the system. So despite of getting access to the system also, I cannot steal the private key, because the private key might be stored somewhere in the cloud, or somewhere in a very secure location. So what I will do, I will just transmit this known plain text to a network. And when I will transmit, automatically it will get encrypted. It will get converted into the cipher text using that hidden key. And that cipher text, as an attacker, because that cipher text will be moving in an insecure channel, that I can steal. And since the known text I know that okay, this is the text, because the text I sent now from this system. So now I got a mapping. I got a mapping in that way that I know the input also, I know the output also. Input is the known plain text which is known to me, and the output also I steal. I know that okay, this is the output. And now definitely machine learning is based on this technique only. If input and output I know, then the logic which is converting the input into the output, that I can very easily get to. And using this technique, we can determine the key. We can identify the key. So I will make one small diagram. It will give us some clarity. What is now? We have the sender, we have the receiver somewhere here, and we have the cipher text somewhere here, and we have the cipher text somewhere here. Now the idea is that this sender will send the cipher text. This cipher text will travel through this insecure channel. Then it will be received. This is the sender. This is the cipher text. This is the cipher text. This is the receiver. This is the cipher text. Now the idea is that definitely we will be using a plain text. The plain text will be converted into the cipher text. So here, let us suppose we know the plain text before. Like the plain text is fed by the attacker. So the plain text is known to the attacker. Here the objective is not to decrypt the information, decrypt the message, but here the objective is to identify the key. Because once if I identify the key, then to all the message I can decrypt. Because once I have that key, then to whatever ciphertext I am getting in the decryption algorithm, I will be making use of that same key to decrypt the messages. So for that attacker, what he is doing is that he is making use of his known plain text. What he will, this known plain text, he will feed it into the system of the sender, and he will receive the ciphertext, and the ciphertext he will receive via the stealing that he will know. Somewhere here he will like steal this insecure channel, the attacker. So we have the attacker, so the ciphertext. Now this attacker will steal the ciphertext from the insecure channel. He will analyze it and convert it into the plain text. So here we will analyze it, and here we will get the plain text.
But he already knows the ciphertext. Again, why is he finding?
Yeah, that nice question. This thing is being used by the attacker in the analysis, like in breaking the code, in cryptanalysis. Now, see, I will tell you what is happening here. Like, let us get some clarity. What is happening?
Yes, sir.
See, here the first step is attacker. What attacker will do? Attacker will create a pair of plain text and ciphertext on his system, on the system of the attacker. So attacker will create a pair of plain text and ciphertext. Because algorithm he knows now, encryption algorithm he knows only that he will be using his key.
Okay.
So in the first step, attacker will create a plain text and a corresponding ciphertext, like encrypted text, corresponding ciphertext. And where the attacker will create this, this where he will do this exercise.
The
Like
sender.
no, he will do it his own machine,
Yeah, like he will get the
attacker's machine. Now what will happen in the step two? In the step two, this attacker will share this plain text to the system of the sender. So I will write it like this: plain text is, or to be more precise, known plain text, or no, rather than known, chosen plain text. Chosen plain text is the right word, because this plain text is chosen by the attacker itself now. So this chosen plain text by the attacker, this chosen plain text by the attacker, it is chosen plain text is transmitted to the insecure channel via sender machine. And we know that when this exercise will be taking place, this chosen plain text will be converting to ciphertext. And in the step 3, attacker will be stealing that ciphertext. Attacker will be stealing that ciphertext. Attacker will be stealing that cipher. And he will be making use of that ciphertext. He will be making use of that ciphertext. Like he will be making use of that ciphertext plus the known, the chosen plain text to decrypt, or not to decrypt, to find the key, to find the private key or the secret. So the ultimate goal is that ultimate goal will be achieved. Ultimate goal, the formula for the ultimate goal is this: ciphertext, or to be more precise, stolen ciphertext. Stolen ciphertext plus chosen plain text, because chosen plain text attacker knows, plus ciphertext of this chosen plain text. No, I will call it known ciphertext. I will call it known ciphertext. Known ciphertext. And with all these ingredients, what attacker will achieve? Attacker will achieve the private key. Yeah, please tell.
Stolen ciphertext is the one which he stole from the insecure channel, right? And
Yeah.
chosen plain text is the one he chose and sent to the sender's machine. And from there, it in the sender's machine, it went through the algorithm and generated a ciphertext, which attacker came to know.
That is the known ciphertext.
Yeah.
No, wait. See, the idea is that in the step 1 itself, attacker will choose up the plain text.
Yeah, got it.
And he will create a ciphertext in his own machine using his secret key, any random secret key, because he don't know now what is the actual secret key which is being used by the sender.
Yeah.
So he will make a random guess for a key and he will generate a ciphertext, and that we are calling as known ciphertext.
Okay.
Stolen ciphertext is the one he is stealing from the insecure channel, and chosen plain text is the one which he has chosen. Now, with all these information,
then can you scroll up a bit?
Up or down, like this?
Yeah, here. Sir, why are these arrows there?
Yeah.
If the attacker is doing everything on his computer, then why these arrows are there?
That is right answer. So this arrow we can get rid of because see, we are already getting ciphertext which the attacker is stealing from the insecure channel. Then no point of this now. So this arrow I can get rid of. Like
So
I can.
what I think is the plain text. So he will the plain text he will choose, and he will get access of the sender's computer, and in his computer he the key will be there. So he will run it in his computer and get the ciphertext. And by that,
So wait. So that ciphertext too we are already stealing na, from the insecure channel. The same ciphertext.
yeah, yeah.
Yeah, so here, yeah, though, like, let us not draw that arrow, but it is the no ciphertext. Like, we can draw something. I will write it. It is the no cipher.
And why is that the from the plain text? Why is the arrow coming to the sender?
No, that is right now. Because see, this plain text, it will be transmitted to the sender system by the attacker.
Yeah.
And the sender system will make use of this plain text. It will encrypt. And during encryption, it will make use of a private key. And the sender system will convert this plain text into ciphertext.
And send it through insecure channel.
And send it to insecure channel.
Then we will get to know the ciphertext, and then we can analyze the pattern. Yeah. And so then to here, stolen ciphertext and known ciphertext are both the same, right?
No. They will be different. Why they will be different? Because see, known ciphertext we got from a random private key, which the attacker just made a guess. But stolen ciphertext we got from the actual private key, which we have to predict. Now,
okay, why we don't need the known ciphertext. We have the plain text and we have the ciphertext of it. So why do we need known ciphertext?
It will mathematically it will make the task of predicting the key easy. It will make the prediction easy.
But this thing he has taken randomly, right? For the ciphertext, the key he has taken randomly. It can be anything. It might not be even close.
So the idea is that for the same text using the same algorithm, if you use different keys also, more than 70 to 80%, the ciphertext will be similar. I hope you are getting my point. My point is that I have a plain text. I can use any key to make to create a ciphertext, and I am making use of an original key to get that same ciphertext, like different ciphertext. Now, comparing the differences between the two ciphertexts, mathematically it is possible to predict the secret key or private. Like this technique do exist. Like now we are not going into that much detail. Now our goal is to just become aware. Like okay, chosen plain text attack also exists and how it works. Now the mathematics of it and all that we can like look into later on.
Yeah, okay.
So predicting private key, or we call it the secret. And here is the magic, because once we were able to predict the secret key, once we were able to identify the secret key, then though the system is compromised. The system is compromised to such an extent that all the information, all the data packets, despite it is encrypted, despite it is encrypted with a very strong encryption algorithm, there is an attacker who has the secret key using which he can very easily decrypt all that information, and information will get leaked, and hence the confidentiality of the system will be compromised, the integrity of the system will be compromised, and
but they can use the different keys every time, right? Who will use the same key again and again?
But here in this the problem is that in this private key cryptography, if you are making use of different keys, then you have to share that different the receiver also, because receiver will be needing the same key for decryption. Like there is a possibility, and this possibility is what we discuss.
Okay.
This possibility is what we discuss. Okay. So this is chosen. So we looked into two attacks, known plain text attack and chosen plain text attack. Now let us see what we can. Now we can look into the next one, that is the chosen ciphertext attack. So I'm also using, I will become familiar with it, but it's interesting that at least our notes are getting saved. So now we are discussing chosen chosen ciphertext. Quickly we will do this. So this is very similar to the previous one. So here the key is that here in the receiver end, yeah, let me first draw it, then we will try to understand it. It's too complex. So first we have a sender in our architecture. Then we have a receiver. Then we have a ciphertext. Then we have the ciphertext. Now this ciphertext, it will be traveling through this unsecured channel, insecure channel. Now what we will do, we will quickly draw this. Now this is the sender. This is the ciphertext. That is the encrypted text. Then we have the receiver, and he has the ciphertext.
Oh,
Okay. What happened?
nothing. Like by mistake, I moved this line.
Oh, okay. You can also access my stuff. Okay, it is a collaborative work. Now, this is very interesting for us to understand. Like, we have to think it, we are trying to attack this system. From that mindset, we have to think, look at it. So, we have an attacker in between. So, this is the attacker. Now, this attacker basically, he will get that plain text and also he will steal the ciphertext. So this is the ciphertext. This is where analysis will be taking place. He will try to predict the key, identify the key, secret key. He will analyze the ciphertext and he will apply some jugaad to identify the key. Now, in this attack, what he does is that chosen ciphertext attack. Now, the idea is that let us understand this. He will choose one ciphertext because see, the receiver has a decryption algorithm, and what decryption algorithm will do? It will make use of its own key,
Yeah.
and it will take ciphertext and convert it into the plain text.
Yeah.
So now, what the attacker will do? Attacker has a known ciphertext. Attacker has a known ciphertext or the chosen ciphertext. So this is what is the chosen ciphertext. Now the attacker feeds this chosen ciphertext into the system of the receiver.
Well,
And
it's random ciphertext.
yeah, so now the attacker will choose any random ciphertext. If it's any random ciphertext, he will choose which he knows, and he will feed it into the system of the receiver. Now the system of the receiver will decrypt it using the original key which we want to identify, and it will create a plain text. It will create a plain text. Now that attacker has access to this plain text also and this chosen ciphertext also, and also attacker will steal the ciphertext which is been sent by the sender.
Yeah. Using these three, he will analyze the key.
Yeah, that is right. Using these three ingredients, he will be able to analyze it. So just so this is accessible to the attacker. So attacker make use of these two information and the ciphertext to predict the plain text or to predict the key or key also. Because once the key is predicted, then the system is compromised.
Yeah, but for first you will need to have access of the receiver's system, right?
That is mandatory. In such kind of an attack, having access of the sender or receiver system is mandatory. So here the formula is this: chosen ciphertext, chosen ciphertext plus chosen ciphertext, okay, plus plain text, or I will call it known plain text, because for that chosen ciphertext I will get known plain text from the decryption algorithm plus stolen ciphertext.
Used to find the key.
Used to find the key. That is so with these three ingredients, we will get the key.
I heard 3 idiots.
No, the ingredients. Yeah, 3 ingredients. Predict the private key, and once the private key we are able to predict, then the system is compromised, and we call the private key as the shared.